call a to the minus 1 is the identity. Then this is the inverse. Then a has inverse. In math, they call a is non-singular. Non-singular. Okay, a is non-singular. And a to the minus 1 is this. Okay, but see that. Suppose in case the order 2, it took us some time to find the inverse, and sometimes it fails. We cannot find the inverse, and we say that it is impossible, and the matrix is singular, because we don't find the inverse, because we can prove that the inverse doesn't exist, But see, suppose that A is equal to A11, A12, A21, A22. You don't know the entries, but it is 2 times 2. A square matrix or order 2. Let's call the determinant of A to the expression. AY1, A22 multiplying minus A21, A12. Multiply the main diagonal elements minus the second diagonal elements multiplication, and then this result is the determinant of A. The determinant is a number always. In our case, since A was 2 minus 1, 3, 1, we have that the determinant of A is 2 minus the product of those, which has a minus. And then the determinant gives us 2 plus 3 equals 5. Different from 0. Whenever you have a square matrix and its determinant is different from 0, it has inverse, for sure. Then it is non-singular, a non-singular matrix. How to find the inverse? Here is the formula. A to the minus 1 in the order 2 is 1 divided by the determinant of A times this matrix. Those elements are the elements of the main diagonal. Just change them of place, this way, in the main diagonal. And second, about those numbers here, just change the sign and no more. And this is for sure the inverse. It is required that the determinant be to be different from 0, because otherwise this formula doesn't work, because we cannot divide by 0. See what happened in our example. A to the minus, the determinant gives us the 5. Then A to the minus 1 is 1 divided by the determinant. And the matrix here is interchange those two, and you get 1, 2 in the main diagonal, and change the sign of those over here in the secondary diagonal. Minus 3 change from plus to minus, and from minus to plus. This is the inverse. Remember how to multiply a matrix by an scalar. Multiply each entry. Then, this gives you 1 divided by 5, 1 divided by 5. This is minus 3 divided by 5, 2 divided by 5. See, remember. Let's compare the answer using a long way, calculating. Remember, I use simultaneous equation and so on, and that's the answer. The same answer, Compare this with this. That's the same. Then, how to know that the matrix has inverse or is not singular? It works for order 2. Find first the determinant. If it is different from 0, it has inverse. It is not singular, and the inverse can be calculated using this method, and you got it easily. See again this video to calculate, to learn to find the inverse of a matrix of order 2.